Okay, so today we'll be talking about Chapter 5, Trigonometric Functions. So let's get right into it. So first off, let's just go over some definitions that you'll need to know throughout the entire chapter. So first you have periodic, something that repeats in a regular pattern. Then we have a cycle, which is one complete repetition of that pattern. We have a period, which is the horizontal length of one cycle. We have the maximum, which is the highest point a graph can go to. The minimum, the lowest point a graph can go to, and then we have the midline, which is the middle between the maximum and the minimum, and then we have the amplitude, which is half the distance between the maximum and the midline. So you could take a look at that graph right here. We could tell the maximum is at the fully top of the graph, the minimum is at the fully bottom, and then we have the midline, and then we have the period and the amplitude. So when we're determining a periodic graph, the one thing we're going to be looking for is a pattern that repeats. So if you take a look at the graph on the left, you could clearly tell that there is a pattern that is repeating, and if you would continue to let that graph continue, that the pattern would continue repeating. Well, if you look at the graph on the right, you could tell that there is absolutely no distinguished pattern, and therefore we would say that the pattern on the left is a periodic function, while the pattern on the right is not. So how do we determine the period? Well, the period is the distance from one maximum to another maximum, or one minimum to another minimum. So if we take the x values of two maximums, one is going to be 5 in this graph, and one of them is going to be 1, and you subtract them, you could actually find the period. So if you take 5 minus 1, you would get 4, and therefore we know that it takes 4 values to complete one entire cycle. So how do you find the amplitude? Well, the amplitude is found throughout the formula of A is equal to max minus min divided by 2. So basically all you would have to do is know the maximum and the minimum, and then you would input the values into the equation. So at Miami Beach, the waves reach a high of 3 meters and a low of 0.5 meters. Find the amplitude. Well, we know that the maximum is going to be 3 meters and the minimum is going to be 0.5 meters. So if we just input that into our equation, 3 minus 0.5 divided by 2, we get 1.25, and therefore our amplitude is going to be 1.25 meters. So 5.2 is all about identifying base, sine, and cosine graphs. Now this right here is a base sine graph. You could tell that the y-intercept is 0, while this right here is a base cosine graph. Now this particular subchapter is not entirely important, but what is important is 5.3. Now 5.3 goes into depth. So first of all, let's just get into how do we find the amplitude from an equation. Well, if you look at the sample equation that I've created right here, the first value, which is our A value, is always going to be the amplitude. Now you always take the absolute value of that A value. So you see how the A value is 3? Even if it was negative 3, the amplitude would be 3. So let's look at this example. So given the equation y is equal to negative 15 cos 100 x minus 300 plus 200, find the amplitude. Well, we know the A value is negative 15, and we know that the amplitude is the absolute value of that A value. So therefore our amplitude would be 15. So how do we find the B value from an equation? Well, the B value is right after the sine or the cosine in our sample problem. Sometimes it is the coefficient of the x inside the brackets, but it all depends if it's simplified. So the B value is given by the formula of 360 divided by the period. So if we know the period, we would find the B value. But if we know the B value, we could also rearrange to find the period. So now let's take a look at this example question. Given the equation y is equal to y is equal to 100 cos 5x plus 50 minus 50, find the B value, then find the period. Well, we know the B value is 50, or B value is 5, excuse me. And so therefore we could just do 3, or we know the B value is 5, and therefore we could just rearrange for the period, so it would be 360 divided by 5, and we know the period is 72. So how do we find the phase shift based on an equation? Well, the phase shift is exactly like the h value, or it is the h value if you remember from chapter 2. Now, if you remember correctly, when you take the h value out of an equation, the sign always changes. And so if the h value is positive, that means you're going to move right. You're going to move left. And if the h value is negative, you're going to move right. And so here we have the phase shift of +3, or we have the h value of -3. And so therefore our phase shift is going to be -3, or 3 units to the left. So now let's take a look at a sample equation. So given the equation 2 cos 5 x minus 10 plus 10, find the phase shift. Well, we know our h value is going to be 10, so therefore our phase shift is positive 10, or 10 units to the right. So how to find the vertical translation from an equation? So we have 3 sine 4 x plus 3 plus 2. Well, the vertical translation is the k value. So if the k value is positive, it's going to be upward, or if the k value is negative, it's going to be downward. So in this case, the k value is 2, so now the vertical translation is 2 units up. So let's look at the example. Given the equation y is equal to 50 cos 300 x plus 5 minus 4, find the vertical translation. Well, the k value in this is negative 4, and therefore we know our vertical translation is going to be 4 units downward. So how do we find the k value given the max and the minimum? So our k value formula is going to be max plus min divided by 2, which is different from amplitude, which is max minus min divided by 2. And the k value is also known as the midline. So if we look at the example, a child is bouncing on a trampoline. He reaches a high of 5 meters and a low of 0 meters. Find the midline. Midline is k value, as we said before, and we know the formula for that is max plus min divided by 2. So if we input our values, our k value is going to be 2.5 meters. So now we get into the challenging part, how to form an equation based off a graph. So first we're going to find the maximum and the minimum, then we're going to find amplitude, then we're going to find k value, then we're going to find period, b value, phase shift, and then we're going to combine them. Now it doesn't matter what order you put them in, but one thing you have to remember is that you have to find the maximum and the minimum first, because you won't be able to find the amplitude and k value without them, so I always like to do them first. So let's actually solve this. So we know that our maximum is 4 and our minimum is negative 2. So if we input that into our amplitude formula, which is max minus min divided by 2, we get 3. We know that the k value is max plus min divided by 2. So if we input that into our formula, 4 plus negative 2 divided by 2, we get the value of 1. We know that b value is 360 divided by the period, and if we look at our graph, we could tell that the period is 90 if we convert it into radians. So our b value is going to be 360 divided by 90, which is 4. Now the h value can be found by taking the x value of the first maximum. So in this case, our h value is going to be 0. And then we combine them into our equation, always putting amplitude first, then our b value, then our phase shift, then our vertical translation. And so our equation becomes 3 cos 4 x plus 1.
5.4 Graphing and Modeling. The learning goal for this lesson is to be able to graph using an equation and to make an equation from a graph. To start off, we will graph the following equation as shown below as a sine function. We can start off by referring to the note above and finding our a, b, h, and k values. To also review, look at the mapping notation ay plus k and x over b minus h. So, the first thing we would need to do is be able to graph our base function as shown below. Now, to transform this function, we would use mapping notation, so we would do x over 1/2 plus 12 and 2y plus 5 to get the following values. We would then use these values to graph. Next, we will use this graph to write the sine and cosine equations. For this, we would have to find our max value, which is 6, our minimum value, which is 2, and our period value, which is 180. So to find our amplitude, we would be 6 minus 2 divided by 2, which is 2. Our k value would be 6 plus 2 divided by 2, which is 4. Our b value would be 360 divided by 180, which is 2. And our h value would be 90. Now that we have all our values, we can plug it back into the cos equation. And to make it into a sine equation, we can add 90 to the argument. Now we move on to our next lesson, which is 5.5, Data Collecting and Modeling. The learning goal for this lesson is to be able to use prior knowledge to solve real-life sinusoidal functions. Question number 1 states, the relationship between a bicycle and a wheel can be modeled as a sinusoidal function. As the wheel rotates, the height of the marker above the center wheel fluctuates between -2 and 2. The wheel has a radius of 1 unit, and the circumference of the wheel is known to be 2 pi. When the outer edge of the wheel has traveled this distance, it has gone through exactly 1 revolution, and so it is back where it started. Thus, if the time at t0 the marker started off at the position h0, then it is back to 0 after 1 revolution. The cyclist happens to be moving at a speed of 1 unit per second. Using the values such as maximum, minimum, and the period that is given above, I can use this to sketch this graph as shown below. Using the information from the graph, I can find the minimum value of -2, the maximum of 2, and the period of 2 seconds. Now I can find the amplitude. which would be 2 minus 2 divided by 2, which would be 2. The k value, which would be 2 plus negative 2 divided by 2, which would be 0. The b value would be 360 divided by the period, which would be 180, and the h value would be 0.5 seconds, as it is the first maximum. Now, using the a, k, b, and h values, I can plug it into the sine equation, as learned from previous lessons. Question number 2 states the height h in meters above the ground of a rider on a Ferris wheel after t seconds can be modeled by the sine function h equals 5 sine 2t minus 40 plus 12. Okay, to start off this question, we're going to find the a value, which is 5, the b value, which is 2, the h value, 40, and the k value, 12, from the equation above. Take the base function of sine and we transform it for mapping notation by doing x divided by 2 plus 40 and 5y plus 12 to get the following values. Using these values, we can make our x and y axis and then plot the points on the graph. Okay, for part B, we're going to find the maximum and minimum heights of the rider above the ground. To find the maximum, we're going to set sine to maximum. As we've learned before, it is 1. So we do 5 times 1 plus 12, which would be 17. And to find the minimum, we would set sine to minimum, which would be negative 1. So it would be 5 times negative 1 plus 12, which is 7. So, part C is asking us to find the height of the rider above the ground after 50 seconds. So, to do this, we would sub in 50 seconds for t and we would solve the equation to get 13.71 meters. For d, we would have to find the time required for the Ferris wheel to complete one revolution, which is asking for the period. So the period would be 360 divided by b, which is 2, and it would be 180. Thanks for watching. I hope you have a better understanding of 5.4 and 5.5 and how to graph using an equation and make an equation from a graph, and also to be able to solve real-life sinusoidal functions.
Section 5.6 is basically a continuation of Section 5.5, so the learning goal is the same. The learning goal is to be able to solve real-life sinusoidal functions. The question we'll be looking at for this section is modeled by the equation P of t equals 750 sine 45t plus 1000. This equation represents the population of deer in a large forest. The first thing we've been asked to find is the initial population of the deer. For this, we just need to sub 0 for t in the equation to get the initial population since no years have passed. So 45 times 0 gives us 0. Sine of 0 is also 0. So we're left with 750 times 0 plus 1000, which is 0 plus 1000, which means we get 1000 deer. So the next thing we've been asked to find is how many years it takes for the population to reach its first minimum as well as its first maximum. Based on the table for y equals sine x, we know sine is at a maximum when sine x equals 1, and this is when x equals 90. So we set 45t equal to 90, and then we isolate for t, which gives us 2 years. This means the maximum population occurs after 2 years. Looking at this table once more, we know that sine x is at a minimum when sine x equals negative 1, and this one x equals 270. So we set 45t equal to 270, and we isolate for t, which gives us 6, which means it takes 6 years for the population to reach its minimum. Part C of the question is asking us to find the maximum and minimum populations. Based on the previous question, we know it takes 2 years for the population to reach its maximum, so we substitute this value into the original equation. 45 times 2 is 90. Sine of 90 is 1. 750 times 1 plus 1000 will give us 1750 deer. Therefore, the maximum population is 1750 deer. Based on the previous question, we also know how long it takes for the population to reach its minimum, which is 6 years. We then substitute this value back into the original equation. 45 times 6 gives us 270. Sine of 270 gives us negative 1. 750 times negative 1 plus 1000 gives us 250. Therefore, the minimum population is 250 deer. To graph this equation, we must use the mapping notation formula. Here's our formula set up for this specific equation. The x and y values we sub in are the sine x equals y values from that table that we've used earlier on as well. The final values for the first cycle of this equation are here. The final section for this unit is section 5.7. The learning goal for this section is to be able to solve trigonometric equations using special angles for sine, cos, and tan. The simple problem we have here is to solve cos x equals square root of 3 over 2 for 0 to 360 degrees. By looking at the special angles chart, we know that when cos equals square root of 3 over 2, it equals 30 degrees. By looking back to the equation, we know that cos is also positive. So, the only two quadrants where cos is positive is quadrant 1 and 4. This means that the first x value is going to be 30 degrees, and our second value is going to be 360 minus 30, which gives us 330 degrees. Here, we have a more complicated question where sine 3x equal to 1 over square root of 2 for 0 to 360 degrees. So to get a more simple variable, we set 3x equal to y. So we get sine y is equal to 1 over square root of 2. Then after, we do the same thing we did the first simple question, where we use the special angles chart and our cast rule to find our two values. So we get 45 and 135 degrees. After this, we have to expand y back into 3x. After we isolate for x in both situations, we are left with 45 and 15 degrees.